So far, we've used our consumer choice theory model to look at price change where the price of CDs became cheaper and the substitution effect outweighed the income effect. The result of that was an increase in the consumption of the thing that got cheaper and a decrease in the consumption of the price of the thing whose price remained the same. Let's apply this framework to an entirely different trade-off than two goods, than the two good case. Maybe not entirely different because we're going to treat them like goods. So the things that we're going to call goods now are not typically looked at as goods, but that's what we're going to do, and it'll work kind of interestingly. Let's suppose that one good that we could purchase is called leisure. And leisure is time spent not working. I'm going to put that up here on my vertical axis. The other alternative to leisure, I'm going to call consumption. And consumption is a trade-off with leisure because the more we work, the more money we have to consume. The less we work, the more leisure time we have. So we do have this trade-off in our lives, right? Depends on how much we make. Like, the more we make for a given level of leisure, the more consumption we can have. That's why we like to make more money. Part of why we like to make more money. We can get more stuff without necessarily working more hours. If we don't get a raise, the way to get more stuff is to work more hours, and that takes away from leisure. So we do face this trade-off, and we can have a budget constraint on these things, just like we can with pizza or CDs. It would look something like that. And what this tells us is this is spending all of our time working. This is spending all of our time in leisure, not working at all, because that's not consuming anything. That's zero consumption. That is sitting around doing no work and having nothing, no goods or services that you can buy because you're not doing any work. And yes, there are ways to get consumption without working, and that's where you can apply this model to see how people might behave when those options become available. And that's kind of higher level than we need to go, but that's where this thing can be applied, and it's really neat when you can get there and do that. We're not there yet. So that's what that is. Out here is working every waking hour. Every hour that's available, not sleeping, is being spent at work, and that's the most consumption this person can have, but that is enjoying zero leisure time. So that is the budget constraint that we all face. Okay? And we do have some indifference curve that we each face between these. And the highest indifference curve that we can obtain is the one that is just tangent to this budget constraint. And so then we have our optimal consumption bundle, and this tells us how many hours we would be expected to work. And again, L here stands for leisure, not labor. Actually, they're kind of opposites in this case. They just happen to both start with L. But let's suppose that just like the CDs got cheaper, you get a raise. Now, getting a raise is nice because you can buy more stuff. Now, some people, and I am kind of like this, some people might choose to take a raise, and instead of buying more stuff, they work less. That would be buying leisure with the raise. But I'm going to model this for the more typical expectation of the laborer, and what data say more often, not always, is the case. So if I get a raise, what does that mean? If I didn't work at all, could I get more leisure? No, because that's already, this point right here is already not working. So a raise wouldn't matter. You don't work, so an hourly, what you make, it doesn't matter. You're not paid if you're not working. But if you didn't have any leisure and you spent all of your time working and you got a raise, you could consume a whole lot more. So just like we did with the CDs, we're talking about this budget constraint swinging out like that. So let me see if I can draw that. A lot of times with the second one, I have a hard time drawing a straight line. Okay, that was a pretty good straight line. Now, notice I'm no longer confined to that same indifference curve that I used to be stuck on. I can move out to a higher indifference curve. Now, I already know, because I thought about this question ahead of time, that I want, just like I had in the last example, the substitution effect to outweigh the income effect. I know that because I know what I want this to look like in the end. So what I'm asking myself for that to happen is the substitution effect. That's the one that is what I would do if I had to stay on the same indifference curve. Well, if I was on this indifference curve, which I'm not going to stay on, but if I had to stay on it, on this new budget constraints slope, I would be moving this way because the flat parts of this budget or this indifference curve are this way, and that bright red line is flatter than the old budget constraint. So if I were confined still and staying on here to match the slope of the new budget constraint, I would move this way. So my substitution effect is going to go, if I can get my things to cooperate, this direction. That's substitution. And I know I want it to dominate. So that means, and the income effect, let me back up. The income effect is just moving out to the next curve, to the other curve. The word other starts with the vowel, income starts with the vowel. The income effect is all about just going to the other curve. The other curve, at a glance, is clearly out on both directions. So income wants to go this way and this way. And they disagree over here. And as I said, I know I want my substitution effect to win, so I'm going to draw a point of tangency and thus conclude that my indifference curves were shaped in such a way, again, I like to think of grooves on a record, that my point of tangency is one where income lost to substitution. And that must result in that outcome where leisure has fallen and this person's consumption has risen a lot. Consumption became more attractive because of the higher wage. The person reacted because substitution is real reaction and shifted to that thing that is very rewarding for right here and right now. So let's think about what we've actually been able to draw here looking at this thing. We had a change from point A to point B. There's no A and B labeled there, speaking, analogously. We had a cause and effect. One thing happened, another thing occurred, and we had just two observations. We had a wage before and a wage after. We have consumption before and consumption after, but we're not interested in that right now. I'm interested in that leisure. That leisure before and after. Leisure fell. If all you can do is spend your time working or in leisure, and leisure fell, what does that mean about the time you spent working? It must have gone up. So I have wages, a change in wages, and I have a change in this person's willingness or ability to work in response to those wages. Is this starting to sound familiar? This L stands for labor hours. We had a low wage, and the person was working the total hours available minus L star. Then the wage went up, and the person's leisure went down, which means they're working more. So their labor went up. So the wage went up and labor went up. What we just illustrated was a segment of this person's labor supply curve. The steepness or the slope of the labor supply curve depends upon whether the substitution effect or the income effect is what is winning in this person's psyche. For some people, and I think I might be one of these people, the income effect wins, and that would imply that if they got a raise, this arrow would have dominated here, and labor sorry, uh, leisure would have gone up. If leisure goes up, this is actually a different color. No, that's not going to work for us, is it? All right. If leisure goes up to here or anywhere above L star, that means this person's buying leisure with the wage. Now, there have been studies that have found that this has been true in the field of nursing. Nurses get raises, and as their wage goes up, not all nurses, some nurses, enough that across the field, this is what the field shows. Doesn't mean it's true for everyone in the field. As wages have gone up, the supply of labor has gone down. That's called a backward bending, because supply curves are supposed to be upward sloping, right? Backward bending labor supply curve. It's unusual, but not impossible if the income effect is stronger than the substitution effect. And I think the reason this is, I haven't read the actual studies, but I've heard about them. I suspect that the reason that is so is because nursing is still predominantly female dominated as an occupation, predominantly, and particularly because it's female dominated at higher wages, these are folks who are able to stay home because they're making higher wages and not work as many hours as when they were making lower wages. And that's vexing for employers or for hospitals, right? Because what do you do if you want to get more people to work? Cut their pay? That's what the model would suggest. So it's a bit troubling, and I think a little bit, just a little bit, maybe, touch, interesting, and something to think about. Again, the blue line here is what we should expect, upward sloping labor supply curves for most fields. This blue line. The orange line is called the backward bending labor supply curve. Quite rare, just interesting, and only going to happen if the income effect outweighs the substitution effect for that individual, for individuals in that field. So that's a little bit more about our model and a little bit of an application of our model. I thought it was pretty fun. I hope you did too.